Scaling modern AI/ML workloads demands infrastructure that is powerful, reliable, and ready to use out of the box. And today I am excited to guide you through how Vultr's GPU solutions are designed to simplify the deployment of AI/ML and HPC applications, ensuring optimal performance and reduced setup times. In this tech talk, we'll start by exploring the key advantages of Vultr GPU-enabled images, including their pre-installed softwares and infrastructure reliability. Next, we'll highlight their unique capabilities. Finally, we'll review Vultr's GPU options from cloud-based GPUs to bare metal servers, showcasing how they cater to diverse use cases. Let's begin by discussing the key advantages of using Vultr GPU-enabled images for your AI/ML and HPC workloads. With Vultr, you get images that comes with pre-installed softwares which are essential for AI/ML workloads, saving you the hassle of downloading and configuring them yourself. This allows you to focus on your work and instead spending time on initial installation and configuration. These images are designed for rapid development, whether you are running experiments or deploying production workloads. You can get started in minutes with minimal configuration. Our GPU images are tuned to extract maximum performance from the underlying hardware, ensuring your applications run smoothly and efficiently. Reliability is critical, especially when handling demanding workloads. Vultr's infrastructure has been rigorously tested to provide stable and consistent performance. Time is money, and Vultr helps you save both. These images eliminate the need of manual software installation and optimizing, allowing you to hit the ground up and running. Now let's take a closer look at the software pre-installed with Vultr's AMD GPU-enabled images. These are designed to maximize the performance of AMD GPUs. The latest AMD GPU drivers are included, ensuring optimal performance and capability with modern AI/ML frameworks and HPC applications. ROCm is AMD's powerful software platform for AI and HPC workloads. It includes tools, libraries, and frameworks optimized for AMD GPUs, enabling seamless execution of demanding tasks. To simplify application deployment, Docker is pre-installed. This allows you to containerize and manage your applications effectively, enhancing portability and scalability. For NVIDIA GPU-enabled images, Vultr provides robust softwares tailored for high-performance compute and AI workloads. NVIDIA GPU drivers ensure that your NVIDIA GPUs are fully operational and ready to support complex computational tasks. NVIDIA CUDA toolkit is essential for accelerating parallel computational tasks. With the toolkit pre-installed, you can leverage the full power of NVIDIA GPUs for tasks like deep learning and data processing. NVIDIA Container Toolkit provides supports for containers, enabling seamless integration of GPU acceleration in your containerized applications. Just like the AMD images, Docker is included here to facilitate application containerization, allowing for easier deployment and scaling. Finally, let's talk about the hardware options available at Vultr. Whether you need cloud-based flexibility or bare metal performance, Vultr offers solution to fit your needs. Vultr provides a range of NVIDIA GPUs for its cloud platform, including models like the A16, A40, A100 Tensor Core, and the cutting-edge L40S. These GPUs are ideal for scalable multi-tenant environments and support a variety of use cases from AI to data analytics. For users who require dedicated hardware, Vultr offers bare metal GPU servers. These feature powerful GPU servers such as the AMD Instinct MI300X and NVIDIA GPU models like the A100 Tensor Core, L40S, and H100, and even the GH200 superchip. Bare metal ensures maximum performance and isolation for the most demanding workloads. With these options, you have the flexibility to choose the infrastructure that best aligns with your project's requirements. Next up, we have a demonstration in which we are going to be provisioning Vultr's normal compute servers and servers with GPU-enabled images. We are going to test the difference between both these servers and also check the pre-installed softwares that comes with GPU-enabled images. In this demonstration, we are going to be provisioning a normal Vultr compute server and a GPU-enabled image Vultr server, and let's see what is the difference. So here, let's click deploy server. So we are going to be selecting a normal compute server, so we'll go with dedicated CPU. For location, I'm going to be selecting Delhi NCR. For a plan, the minimum plan is doable. Now let's configure our instance. Here I am going to be selecting Ubuntu with the latest version. And I am going to be providing a label. Scrolling down, you can see many additional features for your server security and reliability. So my server is all configured. Let's click deploy. As you can see, a normal compute server is deploying right now. Now let's go ahead and deploy a cloud GPU server with Vultr GPU-enabled images. Let's click deploy, new server, select cloud GPU, a location near me, Bangalore. As you can see, there are many GPU options from NVIDIA ranging from A100 to A16s. So I am going to be selecting a A16 server. Next, let's configure our server. For marketplace, I am going to be selecting Ubuntu. For label, let's provide it a label. Scrolling down, you can select any additional feature for your server security and reliability. Now here, let's click deploy. As you can see, within a matter of few minutes and just a few clicks, we were able to deploy two Vultr servers, one with GPU-enabled images and one a normal cloud compute server. Now let's wait for them to provision and then we'll go ahead and SSH into these servers to know the difference between a normal compute server and servers with GPU-enabled images. Once the servers are provisioned, you have to SSH into them and test out the pre-installed softwares in comparison to the normal compute server. So here on my left, I have a normal compute server. Let's run a Docker command to check if the Docker is already installed. Here you can see the Docker is not installed. On the right, I have a GPU server with GPU enabled images. Here, let's check the status of Docker service. As you can see, our Docker service is up and running. That means the cloud GPU server with GPU enabled images comes with pre-installed software. Now let's go ahead and try out a few more commands. Because this is a NVIDIA GPU, we will type in NVIDIA SMI. As you can see, NVIDIA SMI seems to be not there. Now let's replicate this command into the cloud GPU server. As you can see, we can see the status of our GPU card with the help of pre-installed softwares. This is how you can use Vultr GPU servers with GPU-enabled images to execute your HPC workloads in a more fast and efficient manner. If you want to install a bare metal server with GPU access, you can go ahead and select the bare metal option and select any GPUs which are available with bare metal to enhance your AI and HPC workloads. Thank you for taking the time to join me today and explore the powerful capabilities of Vultr GPU-enabled images. It's been a pleasure sharing how these solutions are designed to streamline your AI/ML and HPC workloads, helping you save valuable time while ensuring top-notch performance and reliability. I hope this tech talk provided you with actionable insights into how Vultr's offerings can support your journey, whether you are building cutting-edge AI, conducting complex simulations, or scaling innovative applications by leveraging pre-installed softwares, optimized infrastructure, and flexible GPU options. You can focus on what matters most. I hope to see you in the next one.